What's going on, everybody? I want to do a video today on statistics. And when literature meets mathematics, occasionally magic is made. Mark Twain, he said that there are three types of lies: lies, damned lies, and statistics. Um, Great line. I don't even know if he understood how true that statement is, but I want you all to genuinely consider this video moving forward. Um, when it comes to statistics, they have to be correlated. Unless your goal is just the surface data, you have to actually correlate a statistic. This sounds really boring, but it has, everyday applications, and hopefully you'll use it moving forward. So, when it comes to statistics, and for the record, so everybody knows, this is nicotine for anybody that cares. I do take THC gummies, so I don't care if anybody likes that or not. Statistics can get very confusing, and a lot of people hate math, and that's fine. But when it comes to why statistics are lies, this is very simple. If you have 99 people, okay, and they all die at a different age, 1 through 99, all right, the average life expectancy is easy. It's right in the middle, 50 years old, okay? 50 years old is the average. 1 through 99, 99 people dead, 1, 2, 3, all the way up to 99. The average life expectancy is 50 years old. And yet, and I won't bore you with ratios, and yet, it is the least likely age that you will die at. How's that humanly possible? Well, statistics are made up of the grouping of the data. They are byproducts, okay, by nature. So you're telling me that one person out of 99 died at 50 years old. That means that 98 people did not die at 50 years old, okay? And everything is a 1-to-1 ratio here because everybody died at a different age, all right? So the average life expectancy, if there are 99 people and everybody dies at a different age, is 50 years old. And yet, your chances of dying at 50 years old are 1 in 99. Okay? So it's a 1 to 98 ratio. All the ages on the table, there are 98 chances to not die at 50 years old. So if you just looked at the average life expectancy in that scenario, you might tell yourself, I'm going to die at 50, like that's the average. No. Nothing could be further from the truth. You're actually more likely to die at every other age except for 50. Go to the other end. Okay. Now, everybody dies at 50 years old. 99 people, everybody dies at the age of 50. 50 is now your average age. But it's not anymore. It is now your only potential. Okay? So you erase any minimum, maximum, etc. because at the maximum potential here, you now reach, this is the only age anybody dies at. When it comes to evolution and stagnation, overspecialization leading to stagnation, while you'd like to say, okay, well, I'm definitely going to die at 50 years old. Everybody dies at 50. The issue there, once you start accounting for all the factors of life, people would then start dying younger and younger, okay? Overspecialization leads to stagnation. So when you're actually discussing this subject specifically, you end up realizing that if everybody died at 50, it's the ticking time bomb to when people die at 49 and 48 and 47. So you might think to yourself, I will probably die at 50 years old. And yet, it's probably not true because of the way that evolution works. And And if you're that evolutionarily regressed, you've reached a certain point here, a precipice. Okay, when is the statistic actually true? If you have 99 people that all died at a different age, or I should say half of them die at the same age, half of them die at every other age around the middle. So 49 of the people to 50 of the people die at the age of 50. But then every other person dies at 49 and 51, 48 and 52, 47 and 53, all around the age of 50. Well, then 50% of the people dying at 50 years old in that scenario, now, at that point, you are more likely to die at the age of 50 years old. Understand that what happens is you end up with a minimum average, a maximum average, and an average average. And I'm not making that up. When it comes to statistical analysis, everything has to be correlated. Everything. Doesn't matter what the subject is. Everything has to be correlated. If not, you end up, again, in the scenario where the statistic is just an outright lie. You see 99 people die, and you ignore all of the data, and you see, okay, the average life expectancy is 50. And you start telling people they're all going to die at 50. That's the average life expectancy. But it turns out, no, that only one person actually dies at 50 years old. Everybody else is dying all around it. And that's what made it the average, okay? So I bring that up because of the arguments over statistics and over all of these numbers on paper all of the time, where people just find a statistic and they throw it out and they throw it out and they say, this is true, this is true. A statistic is technically true because it's just data, but it's not correlated yet. They haven't actually broken down that this means this, X, Y, Z, etc. So just remember that moving forward, that when anybody tells you that this is the average, that, you know, this is the statistical average for this, it means absolutely nothing in the grand scheme unless it is correlated. Why is this the average? You know, I can understand that as a byproduct, this is how it came out in the wash. Why? You always have to ask that question. And again, this is why philosophy is so important in physics, mathematics, any of your field work. If you cannot ask the question of why, you will just find yourself repeating things and adding caveats to it that make it untrue, that just make the statistic untrue as you're presenting it. And so, to sum it up again, there is a minimum average, an average average, and a maximum average. And so an average this or an average that is not actually giving you any tangible data that you can sink your teeth into. You actually have to dissect the data and figure out what was collected, how, why. This is why there used to be so much emphasis on peer review for anything. And it's because if we do not scrutinize statistical data, we could be doing the exact opposite thing of what we should be doing. That's how important it is. So I just wanted to touch on that. I don't always do math videos about specific things like this. So let me know what you think in the comments. If there's anything related to math, chemistry, biology that you want me to address or talk about or try to flesh out related to the book or not, let me know. Like, share, subscribe, all that fun stuff, and I will see you all in the next one. Thanks.